All right, so we're going to start with difference of two perfect squares. And the thing that you need to know is that when you are factoring, if you recognize this setup, then these are a piece of cake. And they're usually easy to do when they're the only things you're looking at. But they have like little snipers that live inside other factoring questions. You have to be careful and look for the pattern. The key and most important thing is that there must be a subtraction. Now, sometimes people like to try and factor them with a plus sign, but you can't. It's not a thing. So if you have perfect squares, but it's a sum, you cannot do it when there's squares. Okay, it must be subtraction. Otherwise, it's not possible. The second piece that you're looking for is that you have to be able to take the square root of all terms, and they have to come out clean. So like 25 and 36, 100, 144, 400, all of these square roots, you have to be able to take the square roots of all the terms in the problem. The other part of this where you're taking the square root is for variables, okay? And the key and important thing to know about the variables is that the variables have to have even number exponents. If they have odd number, they can't be factored using this method. So variables must have even number exponents. So if you can identify that all of these things are in place, there's a subtraction, you can take the square root of everything, and all of your variables have even number exponents, then you are set to get started to factor the question using this method. This example represents the basic difference of two perfect squares model. The reason being is you've got two terms separated by a subtraction sign, and the variables have even number exponents. So this one is ready to be factored. When you are doing a difference of two perfect squares, you're going to have two sets of parentheses. And what you're going to do is for the exponent, you're going to divide them into two equal parts. So essentially, x squared is going to divide into x times x. Similarly, y squared would be y times y. The last piece you need to recognize is that that minus sign when you're multiplying means that you have to have opposite signs. So one's going to be a plus and one's going to be a minus. So recap, make sure that you have one plus sign and one minus sign. Also, make sure that you're dividing your exponents in half. In our next example, what you're going to see is that we have the x squared minus the y squared, but they've introduced constants that are coefficients in front of these variables. The question is, can I take the square root of 4 and can I take the square root of 49? Of course, they're perfect squares. So we're going to follow the same model. We're going to have two parentheses. You're going to take the square root of 4, which is 2, and you're going to put those in the front two positions. And of course, divide x squared into two equal parts. We're going to take the square root of 49, which is 7, and that's going to go in the last two positions. And we know we're going to separate our y squared into two parts. Don't forget that you need one plus and one minus sign, because when you multiply a positive times a negative, you get a negative. And that's how you end up doing this problem. Hopefully you're starting to see a pattern and that you're able to recognize right away that this is a difference of two perfect squares. You can take the square root of 81 and you can take the square root of 100. Notice that minus sign. It can only work with minus signs or subtraction. And of course, these are even numbered exponents, so I can make my two parentheses. The square root of 81 is 9. The square root of x squared is x. The square root of 100 is 10. And the square root of y squared is y. Don't forget, you need a plus sign and a minus sign to finish off this problem. Now that you kind of have the hang of this, I want you to take a look at example 4. Example 4 might not resonate to you as a difference of two perfect squares, but it is. How do we know? We've got two terms, both variables with even exponents and a minus sign between them. That indicates that we can factor this using the difference of two perfect squares model. What we're going to do is have two sets of parentheses. We're going to split our a to the 6th in half. So we're going to have a to the 3rd and a to the 3rd. Similarly, we're going to do the same thing with b to the 4th. We're going to cut that in half. So that's b squared and b squared. Don't forget to finish off with a plus sign and a minus sign. We're almost done. We're going to take a look at this example. Notice there's a minus sign. Square root of 25 and square root of 9 are possible. And our variables have even number exponents. So we're going to make our two parentheses. 25 is 5 times 5. A to the 8th is going to be split into a to the 4th times a to the 4th. 9 is 3 as the square root, and b to the 4th is b squared. Now I'm going to make sure that I have a plus sign and a minus sign. Last example. So we have an a squared b squared minus 36. This is a difference of two perfect squares. Notice that I have two terms separated with a subtraction sign. Don't forget, I can take the square root of 36, and my exponents are both even for my variables. So that means that we can make two parentheses. We're going to split these variables in half, so we have a and b in the front. 36, the square root is 6. And then, of course, we're separating this with a plus and a minus. Contact your teacher if you have questions on this method.